Inequalities in two triangles. We're going to discuss today the hinge theorem. In particular, we're going to start with the SAS hinge theorem. There's technically a SSS version of this, which is effectively just the converse, but really all I'm going to try to relate to you is a couple quick concepts here for you to solve these problems. So let's take a triangle, and we're going to draw another one that looks almost identical to it, right? In my case, I just made it identical, but these ones won't be that way. Remember, don't worry about what the diagram looks like. Worry about what it actually is or what it's marked as. So I have, two sides congruent in a triangle, which is not sufficient proof for it to be two congruent triangles, correct? I would need to have either this third side, which I don't have, or I would need the included angle, which is going to be B and E, right? And in the SAS hinge theorem, so of course here, SAS, we're going to work with that included angle. What it says is the following, is that if I have one of these guys, right, that is larger than the other, one of these angles larger than the other, then the side opposite, and remember, these are the sides opposite, are going to have the same corresponding relationship. In other words, in this case, since 50 is less than 60s, then AC would have to be less than DF. Pretty straightforward. Moreover, we can work it back the other way. So let's go ahead and make two triangles again. It's going to be A, B, C, D, E, and F. Again, I have my two sets of congruent sides. And then on that third side, right, this is that whole thing of maybe SSS, right? But I want us to still consider it the same way. It's the hinge, right? Consider in class what I was able to demonstrate for you with two rulers. There was a yardstick and then a ruler, right? One, a 3-foot length and a 1-foot length. I used the angle that I created with the two of them, and I made a hinge, right? It was made like a swinging hinge that the more I opened the angle, the longer that side that you could construct opposite would be. In fact, we can take a look at that real quick. Something similar. I always like this web app here. That if we take what we have here, these obtuse triangles, take a look. So 203 and 167. I'm going to try to keep this guy as close as I can to 167. But notice as I have that side, 203 stays the same, 167, right? The more I open up that angle, the greater that side is, right? And I'm still going to try to stay true to 167 here as I close the angle, right? And it makes the side opposite smaller, right? It's effectively what's going on here in this hinge theorem. And so if I have 11 and 12 as my sides opposite, right, what I can do is I can now make assumptions about the angles that are opposite. In this case, again, it's that included angle B and E. So in this case, B is going to be less than angle E, and that's because, very simply, 11 is less than 12. All right, so we're going to do a proof. This is not an indirect proof. This is like the old school kind that we did way back in the first semester. We haven't done any of these in a little while. Try to make that triangle again here. Here we go. Oops. Let's make this line a little bit better. There we go. So here we go. And our triangle is ABC with this point D. And our given here is that we have two congruent lines, right? AB and BC. As well as we actually have another line here, AD, which is going to be bigger than BC. And what we want to prove here is that the measure of angle ABD is going to be bigger than the measure of angle CBD. All right, so here we go. statements and our reasons, of course, as we always start our proofs. Now, in the indirect proof, we actually start with the proof step and we did the opposite. That's not what we're doing here today, okay? Instead, what we're doing, again, traditional proof, so we're just going to restate the given as step 1. Okay, so I think this is the thing that we really always like to see, right? Is that, is this hinge theorem going on? Well, I think we prefer to see this, right? We see 1, 2, and then, right? And we have the 2 sets of congruent sides, right? But in this case, this side is shared. It's this guy right here, which is BD. And I think it's sometimes so obvious that we just overlook it. But of course, BD is going to be congruent to itself through the reflexive property. And last but not least, right, what I just illustrated over here, okay, so let's say we have that, and that it's the 2 different ones. Well, we always like to see, right, AD bigger than DC, we want to see some sort of a concrete number. But of course, 10 bigger than 9, in this case, AD bigger than DC. So that angle opposite is going to have the exact same relationship. So we've done what we need to here to prove that inequality, and again, that's being done through that SAS hinge theorem that we just discussed. So that's all we have to write is SAS hinge. Or I actually will accept hinge theorem, but make sure that you do not just write SAS by itself, because that would mean congruence, and these 2 triangles clearly are not. That's all I got for you for today. If you have any questions, feel free to reach out to me. Good luck.